Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, and very good day everyone. So today we meet again. So we're going to learn about a new topic, which is alcohol. So your previous task was completed to identify the preparation of alcohol. So today we're going to see more in details about preparation. More in detail about the chemical properties and physical properties of alcohol. Okay, so alcohol is one of the topic in the organic chemistry. So what we're going to learn today, so we're going to learn in terms of naming, how to name alcohol according to IUPAC nomenclature, and we're going to move into drawing as well, because naming and drawing is a basic skill that all of you need to have in order for you to answer question regarding organic chemistry. And we're going to look briefly on the physical properties of alcohol and the chemical properties, as well as the uses of the common uses of common alcohol that we can find available in the market. All right. Okay, so let's have a look briefly about alcohol as what we normally do in our lesson. So we're going to see about the homologous series that we need to learn. So basically, alcohol is very similar to alkane. However, one of the hydrogen in alcohol is being replaced by hydroxyl group. So if you see the molecular structure of alcohol, you will find that it consists of the carbon chain, which is carbon-carbon chain between carbon, and also it consists of functional groups. Okay, so you need, if you see the functional group in that molecule, which is the hydroxyl group, so it's actually that particular compound or particular molecule belongs to alcohol. So general formula for alcohol, because as you know that the member of homologous series, they have a general formula, and each member of homologous series will comply or will follow the general formula for that homologous series. So Cn H2n plus 1 OH. This is how we normally write the chemical formula for alcohol, and the N value for alcohol start from 1. Okay, 1, 2, 3, and so on. As you can see from on this slide, the molecule that's shown here is actually ethanol. So consists of 2 carbon. Okay, as we learned previously, Eth, okay, representing 2 carbon, and also you can see ol at the end, Ol representing the alcohol. So when we merge, so become ethanol to represent homologous series of ethanol contain 2 carbon, and then the homologous series of alcohol. So we have few more. I showed here is actually 2 example of other member of alcohol, which is butanol, consists of 4 carbon, and hexanol. So you can so basically you can name alcohol based on the carbon compound. So we're going to see after this about the naming. Okay, so this is roughly about alcohol in brief. All right, let's have a look how to name alcohol. Of course, we have what we call a very systematic way in naming the molecule. Okay, so basically we follow the IUPAC nomenclature system. So this is actually the steps that I actually summarized to make it easier for you to name the alcohol. So you can find different steps used in different books, so never mind, as long as you can name the alcohol according to the IUPAC nomenclature, then it's fine, right? So the first step that you need to know when you are given any molecular structure is you need to identify the longest carbon chain, okay, and then of course when you identify the carbon chain, you can actually name based on the alkane. So if you can see over here, okay, we have a molecule, and then the carbon chain will consist of 4 carbon. Okay, so 4 carbon, as in if you name based on alkane, the name should be butane, but this one is not butane. Okay, as you know. Okay, and then when we successfully identify the carbon chain, the second step is you need to number the chain. So this is what you normally do for alkane and alkene as well. Okay, so you name. So from the left to the right and the right to the left, and then what you need to do, we need to identify the position of hydroxyl group, because that position going to determine which numbering that we use is valid. In this case, we if you see the hydroxyl group, okay, the hydroxyl groups is located in carbon, either carbon number 2 or number 3. So we going to allocate, or we going to assign the smallest number for the functional group. So in this case, we're going to take number 2. So which is we're going to use the purple numbering system, and that is the case. We're going to eliminate the second numbering system. So carbon, so hydroxyl group, the position is number 2, and then we need to identify if we have any substituent group. So if you refresh back what we learned before, substituent group can usually can be coming from the alkyl group, or some other group, for example, from halogen. Okay, in this case, we don't have any substituent group, so we can actually proceed to the last part to name the alcohol. So we have the carbon consists of 4 carbon chain, which is if you name according to alkane is butane. So I put on the top, so naming of alcohol, and the letter E for the alkane will be removed, and we're going to replace with OL to represent that is actually coming from alcohol homologous series. Okay, so how to name the alcohol? So 4 carbon is butane, and then we're going to integrate the alcohol naming and also the location of hydroxyl group as well. So the name for this one is butanol, or butane 2-ol according to IUPAC. So butane representing 4 carbon. So number 2 representing the position of hydroxyl group, and OL representing is alcohol. So the IUPAC name for this molecule is butane 2-ol. Okay, butane 2-ol. All right. Okay, let's try for number 1. Can you actually name this compound? Okay, so you can actually pause the video for now. So you can actually try first, and then when you get the name, and then you can play the video back. Okay, so you can pause the video now. All right, so I hope you have the name for this molecule with you. So let's go through together this molecule and give the name for this molecule. Right, so as you are aware that we have 5 steps that I actually listed down over here. So you can try using this step. Okay, first identify, can you identify the longest carbon chain for this molecule? Yes. Okay, we have actually 4 carbon. Okay, regardless how you and you need to remember the longest carbon chain must consist of functional group, because if you see from the slide from here, the longest carbon chain can be also from here. But if you take this the red section as your longest carbon chain, then it's wrong, because it does not consist the functional group. Okay, that's why you need to choose the yellow part, because it should include the functional group in the chain. Okay, so we have 4, so it should be a butane. Okay, number the carbon chain as usual. Make sure that identify your what we call it a functional group. In this case, our functional group is located at carbon number 1. Okay, so that's why we eliminate the green numbering system. Okay, so your hydroxyl group in carbon number 1, and identify if we have substituent group. And in this case, compared to the previous molecule, this molecule we do have the what we call it a substituent group. Okay, so the substituent group is located over here at carbon number 2. Okay, so we have substituent group is carbon number 2, and then we can name the alcohol. So it's very similar to what you did for alkane and alkene. Okay, so you need to give the number for the substituent group first, followed by the substituent group, and then the chain, and then the name of alcohol. So if you have over here, you can see the name is 2-methyl butane 1-ol. So the 2 coming from the location of substituent group, and then this is your substituent group. Okay, butane representing your carbon chain, and then 1 is location of your functional group. In this case, it's actually hydroxyl group, and then the last one, O, representing alcohol. So you can see it's very systematic way in naming the molecule, or in naming the molecular structure, right? So that's basically how you name the molecule if you are given the structure. If you are given the chemical formula, you need to do the same thing. Okay, you need to first identify if the given formula belongs to alcohol by using the general formula, and then you draw. Okay, so now I'm going to show you how to draw, because you need to draw in order to name. Okay, if you are given the molecular structure, you can name straight away. Okay, now we're going to see how to draw the alcohol. All right, so basically drawing, the first step, okay, you need to draw the carbon chain. Okay, of course, after you identify the given formula is belong to alcohol, then you can follow this step. Okay, draw the carbon chain, how many carbon chain that you have. Second step, draw the functional group at the specified location based on the name. Okay, draw the substituent group. Okay, draw the substituent group if any in the specified location. And then the last one, complete the drawing by completing the bond with the hydrogen. Okay, for example, here we have 2,2-dimethyl pentane 3-ol. Okay, as I mentioned earlier, that the naming for the organic molecule is a very systematic. Then you can actually identify the structure based on the name. Here we have 2,2-dimethyl. It means, okay, the first one, you can see, draw the carbon chain. So we have pentane, which is basically we have how many? Yes, true, it's 5. 1, 2, 3, 4, 5. Draw the carbon chain, and then draw the functional group at the specific location. Okay, if you can see, the functional group is located at carbon number 3. Okay, 1, because when you draw, you can actually specify which is actually your carbon chain, the number for your carbon chain. All right. If you have the hydroxyl group, make sure that you draw the bonding between oxygen and hydrogen. Okay, you cannot draw simply like this. Okay, this is not considered considered inaccurate, because you do not show the bonding. All right. So the functional group is located at carbon number 2. And we have dimethyl. So we have two methyl. Where is this methyl group is located? Is carbon number 2. So 2 methyl located both in carbon number 2. How do we know? Because the number is 2, 2. That means both are located in carbon number 2. Okay, we are done. Then the last one, complete the drawing by completing the alcohol. So we can, so basically we can draw now, completing the alcohol, the structure by drawing the hydrogen. Okay, and the hydrogen to complete. Remember, each carbon consists of 4 bonds. Okay. Okay. This is another one. Okay, so basically this is structure for 2,2-dimethyl pentane 3-ol. Okay, so if you follow the step, then it's going to be easier for you to draw the structure. So basically, you can try yourself how to actually, you can try yourself to name and to draw the structure. Okay, so you can refer to your teacher for the answer because it's very straightforward. Okay, you can actually copy down the question and then answer at your own time. Okay, you can discuss the answer with your teacher later. All right. Now, we're going to move into physical properties of alcohol. Okay, I'm going to touch like 4 main properties of alcohol. Okay, the first one, so you need to know that basically what we call it, smaller molecule, the small molecule of alcohol actually highly soluble in water. For example, methanol and ethanol, and then the solubility decreases. Okay, the solubility decreases as the number of carbon increase. Okay, it decreases because the soluble part is actually the hydroxyl group parts, and then insoluble part is actually basically the carbon chain part. So as the carbon chain become longer, so the molecule become less and less soluble in water. And then ethanol is a volatile, so it is actually can turn into gas very easily. Okay, so I believe some of you, when you are a small kid, you tried before when you spray some alcohol, or you actually rub your skin with the alcohol, and then suddenly you see that the alcohol disappear. Some of you might think that alcohol actually what we call being absorbed by your skin, but it's not. But actually the alcohol is actually evaporated or turned into vapor. That's what we call it, volatile. Okay, so volatility also decrease as the number of carbon increase. So basically methanol is highly volatile. So if you just open the methanol or you put the methanol in the evaporating dish, you will find that it will disappear just in a few minutes. Okay, and turn into vapor. All right, so alcohol, don't forget that alcohol is a natural molecule. So the pH for alcohol is 7. As other compound belongs to covalent compound, alcohol also do not conduct electricity. Okay, do not conduct electricity. So this is basically just 4 main properties of alcohol. Physical properties of alcohol. So I'm mentioning over here about ethanol because it's easy if you focus on one particular member of alcohol. You can actually find more information about the other member of alcohol from the data available from the internet or from the books. I think it's going to be easier that way. So you just need to know the trend. You don't have to memorize each member. I mean, you don't have to memorize about the boiling point. You just need to see the trend. So basically, in physical properties, you just need to know the trend. All right, the chemical properties is quite important because alcohol basically can be produced from the other member of organic compound. I believe when you come across where you actually preparing the information about the preparation of alcohol, you come across that alcohol can also be prepared from alkene. Okay, and that's why as we go along between these homologous series in organic chemistry, you will see that they are actually quite highly connected. Okay, so one homologous series can turn into another homologous series by a series of reaction. All right. So there are three important reaction that you need to know. The first one, of course, combustion reaction, which most of what we call most of hydrocarbon and organic chemistry can actually take part in. Okay, so the product for the combustion process is always carbon dioxide and water. Particularly alcohol, they are highly flammable, particularly ethanol. Okay, the first one, methanol and ethanol, a small molecule. In fact, ethanol can also be used as fuel because of this purpose, because they're quite flammable, they're quite clean, and then there's no, what we call it, pollutant produced from the combustion of ethanol. And also ethanol is actually what we call it, is a renewable source of energy, because it can be produced from crops, it can be produced from plants. Okay, compared to like hydrocarbon, which is actually derived from fossil fuel, right? For the second reaction is actually oxidation reaction. This is also quite important because we will come across you will study more about this reaction in our next topic, which is carboxylic acid. So ethanol, if you heat the ethanol with acidified potassium dichromate, you will get the ethanoic acid, which is the vinegar basically. Okay, and then the color will also change. Okay, the structure of color, potassium dichromate will change from brown or yellow to green at the end of the reaction, because the chromium change the oxidation number. Okay, under this reaction. Okay. I believe the equation over here is incorrect. Okay, so for that case, so I want you to find the chemical equation for the oxidation of ethanol. You will see that this equation is slightly unique from the rest of chemical equation. So that's why I want you to find out how to write the chemical equation for the oxidation reaction. Okay, I repeat because this is quite important, so that rather than you see this equation on the slide, I believe if you can find the equation yourself, you will understand and remember better. If you cannot understand, please do consult with your chemistry teachers so they can explain why that particular chemical equation is different from what you used to see it in chemical equation, right? So basically you see from the left is actually the setup. Okay, the setup, basically we heat the mixture, okay, of what we call it ethanol and potassium dichromate, and now we're going to collect the final product in the test tube that had through the delivery tubes, because it's going to turn into vapor. Okay, and then we're going to collect the product as what we call it, the carboxylic acid or ethanoic acid. If you are using ethanol, then you get ethanoic acid, right? If we have a chance, then we will carry out this experiment in laboratory so that you can see more in details for this experiment. All right, the last one about the dehydration reaction. From the name that you know, dehydration means removing water. So basically we are removing a water molecule from the reaction, not from the ethanol, because ethanol, we are removing water based on, because we are removing water from the ethanol, but you might think that how ethanol produce water, because the structure you can see that ethanol consists of hydroxyl group, which is OH. So OH group will be removed together with another hydrogen from the ethanol, so that you will get at the end the product is water and also alkene. In this case, if you are using ethanol, you will get ethene as the product. Okay, you get ethene gas as the product. So I show here this experimental setup that you can carry out in the lab. So basically, we are soaking ethanol with the glass wool, and then we're going to heat the glass wool, and then at the same time and then at the same time we're going to heat the porcelain chip. So when we heat the glass wool, the ethanol will turn into vapor and then pass through the heated porcelain chip, where the dehydration reaction will take place, and then the ethene gas will be collected in the test tube over here, based on the using the water displacement method. So how to test the gas produced? So you know that alkene will give a positive confirmation test with the bromine water. So alkene will decolorize bromine water to colorless. So basically this is the initial color of bromine water. Then after you actually, if this is actually the alkene, then the bromine water will turn into colorless when you shake the gas with the bromine water, right? So this is, you need to remember, a very important test for alkene. How to test for alkene? Basically, we test with the bromine water. So the bromine water will decolorize from brown to colorless. So this is quite important test as well, particularly for organic chemistry. All right. So this that's all about chemical properties. And the last one, just to brief you about the uses of alcohol. I listed down over here. There are actually 5 uses. You can find there are a few more uses of alcohol. Of course, alcohol can be used in a good way or a bad way. It depends on how you use it. So here, of course, you can see most of them is actually for the good purpose. That's why in this topic, you also need to learn about the misuse of alcohol, because if you misuse the alcohol, they will give you bad consequences in terms of what we call it, alcoholic problems and so on. All right. So just to let you know that alcohol is actually what we call it a common organic solvent. So you can use alcohol to dissolve most of the paint or the varnish. Okay, it's quite useful. Also, you can find alcohol in major cosmetics, particularly perfume, moisturizers. Okay, because alcohol is volatile, it's very good in terms of adding alcohol into perfume to make it the smell can actually travel further because of the volatility of the alcohol. As you can see previously in the oxidation reaction, we can actually produce vinegar. So basically alcohol can also be, is a source of chemical. So we're going to see later on alcohol can also be used for making esters as well. Okay, alcohol can also be used as fuel because of the properties, because it's highly flammable, particularly for example, ethanol widely used as the biofuel. And the last one used in medical field. We can use alcohol as antiseptic. So basically, if you get some cuts in your skin, so you can just apply rub alcohol on the cut so that it can actually act as an antiseptic to kill the bacteria and prevent from the infection on your skin, right? So I think basically that's it, all what I want to cover about alcohol, because we already covered the first part about the preparation. So this is the main part. The last part, the remaining part that you need to actually study a little bit more is about the chemical properties, about the reaction, about the experiment, about the chemical, but how to actually do it in the lab. So you can actually do a little bit of reading on that, so that you understand more. You will understand more about the properties. Okay. So with that, so thank you very much for actually staying to watch this video till the end. Okay. I hope that this video give a huge benefit for your learning. So if you have question, feel free to contact me, or feel free to ask your chemistry teacher, and then you feel free to subscribe as well to the channel. And then hopefully if you have a very positive or constructive comment, do leave the comment, and hopefully I can actually improve the slide later on. Okay, thank you very much, and then see you again.